We are used to thinking that the ancient world was simple and naive, and that all complex technologies appeared only recently. But if you take a closer look at some real objects from the past, this certainty begins to collapse. I have seen metal that is 1,500 years old and does not rust, concrete that has been standing for 2,000 years without reinforcement, traces of granite processing that look more like machine work, stones weighing hundreds of tons laid as if they were moved without hesitation, and walls that survived earthquakes because they were calculated, not simply stacked. These are not myths or legends. These are real engineering objects that physically exist and fit poorly into the familiar version of history. If you are interested in understanding such strange failures of the past, subscribe to the channel. Here we talk about what history prefers to remain silent about. Today, we will examine 5 ancient technologies that look impossible. The Iron Pillar of Delhi stands on the territory of the Qutb Minar complex, and at first glance makes almost no impression. No carvings, no ornaments, no demonstrative monumentality. But the longer you look at it, the stronger the feeling that this is not a monument, but the result of a very confident engineering calculation. It is almost 7.5 meters of wrought iron, created more than 1,500 years ago, which has been exposed to open air all this time. Rain, monsoons, heat, and sharp changes in humidity, and yet has never developed the deep corrosion typical for iron. Not that it doesn't rust at all, as is often written, but rather that it behaves anomalously stably. Instead of destruction, a thin protective layer formed on the surface as if preserving the metal. Modern science explains this by the high phosphorus content and the specifics of forging, but this leads to a more uncomfortable question. To achieve such an effect, it was necessary not just to randomly mix ore, but to understand how the metal would behave decades and centuries later. This is no longer craftsmanship, but technological control, where temperature, composition, repeatability, and experience matter. What is especially disorienting about the pillar is that it does not look experimental. It did not crack, deform, or appear to be a successful attempt. It looks like a serial product of its time, simply one of the few that survived. And at this moment, the most disturbing feeling arises. If in the early Middle Ages, someone knew how to create iron with such longevity and embed durability for centuries, then perhaps part of our knowledge of materials was not developed further, but lost, without us even noticing how it happened. The iron pillar makes us doubt the simplicity of ancient metallurgy, but it is only one object, one point in time. It becomes much more unsettling when you realize that this was not a single skill, but an overall approach to materials. And if iron could live for centuries, then what was happening with the most common building material of antiquity? Concrete? Roman concrete does not overturn the familiar picture immediately, but gradually, when you realize that it behaves in exactly the opposite way from how we are used to perceiving this material. Modern concrete ages, cracks, fears water and salt, requires repairs and reinforcement, whereas Roman concrete, especially in marine structures, becomes stronger over time. The most illustrative symbol of this technology is the Dome of the Pantheon, the largest unreinforced concrete dome in the world, almost 2,000 years old, which still stands without a hidden metal frame, without reinforcements, and without modern safety measures. As scientists have discovered, the secret lies in volcanic ash that the Romans added to the mixture, When it comes into contact with water, crystals gradually form inside the concrete, literally healing microcracks. This sounds like a neat scientific explanation, but reality is more complex. We understand the chemistry of the process, can reproduce individual samples in laboratories, but to replicate the same effect on a mass scale with the same longevity and stability remains difficult even today. And once again, there is a sense not of an ancient accident, but of a conscious approach to material. The Romans built as if they knew their buildings would stand for centuries, in the sea, under load, without constant maintenance. This is not temporary architecture and not a display of power. It is technology designed for time. And that is why Roman concrete today looks not like the past, but like a lost branch of engineering evolution. Roman concrete shows that the ancients knew how to work not only with form, but also with the internal structure of material, embedding properties centuries in advance. But concrete is a mixture, plastic and forgiving. Granite is something else entirely, a stone that does not forgive mistakes and does not submit to random solutions. And it is here that the ancients left traces that look especially uncomfortable. The unfinished obelisk of Aswan is valuable not for what it was meant to become, but for the fact that it remained unfinished. This is a rare case where ancient technology is captured not in a completed monument, but in the process of work itself. A gigantic blank over 40 meters long remained in the bedrock because of a crack, and this is precisely what turns the object into direct evidence of how granite was worked, not how the process was later explained. The stone surface is covered with long parallel grooves that look not like traces of chaotic blows, but like the result of systematic and uniform material removal, as if the stone was processed according to a clearly understood scheme. Granite is one of the most stubborn materials humans encounter. It does not respond well to impact processing, quickly destroys tools, and does not forgive mistakes. In the traditional historical narrative, it is believed that the Egyptians used copper tools, stone hammers, and quartz sand as an abrasive. Theoretically, such a method is possible, but in practice the question of scale and efficiency arises. To leave such marks on such a volume, the technology must be not just functional, but productive, repeatable, and designed for large blanks. This is no longer a one-time ritual effort, but a system in which results can be planned, risks assessed, and in case of failure, the project calmly abandoned, exactly as happened with this obelisk. Everything looks as if the craftsmen clearly understood the limits of the material and the capabilities of their tools. The obelisk does not give the impression of a daring ancient gamble. It looks like an unfinished product of a technological cycle. And if we accept this, it becomes obvious. In ancient Egypt, there existed a system of hard stone processing whose level we tend to underestimate today, because it does not fit well with the familiar image of primitive antiquity. This stone does not argue with history. It simply silently shows that history has not been fully told. The unfinished obelisk shows that hard stone processing was systematic and deliberate, not chaotic. But the next logical question arises: if the ancients could work with material in this way, could they just as confidently control its mass? Because carving stone is one thing, and moving it, lifting it, and placing it precisely is something entirely different. The megaliths of Baalbek are a case where the discussion of ancient technologies stops being abstract and runs into dry numbers and physics. In the foundation of the Baalbek temple complex lie stone blocks weighing from 700 to more than 1,000 tons each. Nearby, in the quarry, lies an even more massive block, so heavy that it was never even attempted to be moved. The problem is not that the stones are large, but that they were moved, lifted, and placed with precision that does not allow for crude errors. This is not a pile of boulders, but a foundation designed for load and stability. Even in modern engineering, moving such masses is an extremely complex operation requiring powerful cranes, special platforms, center of gravity calculations, and ideal logistics. An error of a few degrees or centimeters, and the operation turns into an accident. At Baalbek, however, there are no traces of chaotic attempts, collapses, or corrections. The blocks lie as if their installation was not a risky experiment, but a pre-tested procedure. And this raises the main question: by what means did ancient builders control the movement and placement of such masses if, officially, they had neither steel, nor hydraulics, nor complex mechanical systems at their disposal? One often hears explanations involving ramps, rollers, and thousands of workers. But the deeper you look, the weaker this explanation becomes. The mass of the blocks is such that the pressure on supports, ropes, or wooden structures should have led to their destruction. Moreover, this is not only about horizontal movement, but about precise placement at height, while maintaining the geometry of the entire structure. And this is what makes you think. Perhaps for those who installed them, such masses were not something exceptional. Perhaps they possessed methods of working with weight and inertia that were not preserved in texts or drawings. Baalbek does not prove the existence of unknown machines, but it clearly shows something else. The level of control over material and mass was significantly higher than we are used to allowing, and this level still lacks a convincing explanation. Baalbek demonstrates control over weight and inertia on a scale that is difficult to explain even today. But there we are dealing with rare, almost unique blocks. What if such engineering thinking was not an exception, but the norm, simply expressed not in gigantic mass, but in precise geometry, repeated again and again? Polygonal masonry in Peru is a case where technology is masked as aesthetics, and because of this, it was not taken seriously for a long time. The stone walls in the area of Sacsayhuaman and Old Cusco look almost decorative. Stones of different shapes, strange angles, wave-like joints. But once you remove the tourist perspective and turn on the engineering one, it becomes clear. This is not decoration, but calculation. The stones are fitted to each other with such precision that it is impossible to insert a blade between them, while no mortar or binding material was used at all. Each block is unique in shape and works not on its own, but as part of an overall system. The main feature of this masonry reveals itself during earthquakes. The Peruvian region is seismically active, and over the past centuries, colonial buildings constructed using European technologies have repeatedly collapsed here. The Inca walls, however, either remain standing or receive minimal damage. The reason lies in geometry. The stones have complex shapes with many faces, allowing them to slightly shift during vibrations, redistributing the load, and then return to their place. This is not a rigid structure, but a controlled, movable system that works through shape and mass, not glue or metal. To create such masonry, each stone had to be individually fitted to its neighbors, repeatedly removing material, checking the fit, and achieving perfect contact. This requires not only enormous time, but also a clear understanding of why this is being done. If the goal is simply to build a wall, such an approach makes no sense. But if the goal is to create a structure designed to endure decades of earthquakes, then everything falls into place. This is no longer architecture in a decorative sense, but applied engineering hidden in stone. When you look at these walls, it becomes clear. Ancient technologies were not necessarily loud or demonstrative. Sometimes they were hidden in the shape of stone, in the angle of contact, in an understanding of how a structure behaves centuries later. And that is precisely why they look impossible, not because they violate the laws of physics, but because they violate our ideas about the past. When you look at these technologies together, it becomes clear. The ancient world was not primitive, it was simply different. It did not strive to impress, it strove to work for a long time. Metal, concrete, stone, mass, and geometry, none of this violates the laws of physics, but all of it violates our ideas about the past. And perhaps the most important knowledge humanity did not rediscover, but once already possessed and then lost. If this view of history resonates with you and you want to explore its uncomfortable questions more deeply, subscribe to the channel. There are many more topics ahead, after which the familiar picture of the world will no longer be the same.